All right, today we're going to continue on with graphing from equations to determine number of solutions. So you should be on page 8 of your notes. Today we're going to look at a couple of the examples on page 8 and 9. Let's go ahead and start with this first example, number 1. Remember, when we are graphing, we always start with the y-intercept. So the y-intercept is where you want to start your first point. So if my first point is a -4, my first point is -4, then that means my first point I'm plotting is down here at -4. We always look at the slope to tell us how to move. So if my slope is a 1/3, that means I'm going to go up 1 to the right 3. So I'm going to go up 1 and to the right 1, 2, 3. And I'm going to plot my second point. If I were to do that again, you'll notice we go up 1 over 1, 2, 3, we're off the graph. So in order to get a point that's not going to fall off the graph, we can go in the opposite direction. So I could now go down 1 and to the left 1, 2, 3, and get a point right there. So now I'm going to go ahead and connect these with as straight a line as possible. And I'm done with my first equation. So now let's go ahead and graph the second one. This one starts at +4. So my first point is going to be up here at +4. And this slope is a -7/3. So that -7 tells me I'm going down 7 to the right 3. So we're going to go down 1, 2, 3, 4, 5, 6, 7, and to the right 1, 2, 3. So there's my second point. Normally we would want more than 2 points, but we know that we're going to go off the graph here. So I'm just going to connect. And notice that these two equations crossed right there. And that ordered pair, my x value was a 3, my y value is a -3. And because they crossed, this has one solution. This one has one solution. All right, let's take a look. We're going to skip down to number 3. And if you want to pause this and go ahead and try graphing the first equation for number 3, go ahead and do that. So we know that we're going to start at -3. And from there, my slope is a -7. Anytime it's a whole number, we know we can put it over 1. So this tells me I'm going down 7 to the right 1. Well, if we notice, if we go down 7, we're going to be off the graph. So I can do the opposite. I can go up 7, but to the left 1. So let's do that. 1, 2, 3, 4, 5, 6, 7. But we're going to go to the left 1. And that lets me plot that point right there. So if let me get rid of some of these little squiggles here so you can kind of see it a little better. So that's my first graph. My second graph, I notice all it says is y equals 4. We know that slope-intercept form is y equals mx plus b. This one just says y equals 4. So technically, I'm starting up here at +4, and I have no slope. Having no slope means I'm not moving up or down. I'm staying right at +4. So that tells me that my line is going to stay right at +4. So on this one, they both go through that ordered pair. And that ordered pair is -1, +4. Because they do cross in one spot, then there is one solution. Okay, let's skip down and look at number 5. One thing I notice right off the bat on number 5 is that there is something in this equation that's similar. So if we notice, both of these have the same slope. And if you recall from our notes, equations that have the same slope will end up being a specific type of a graph. And if they have the same slope but different y-intercepts, then you're going to end up with parallel lines. And parallel lines have no solution. So let's go ahead and graph these. My first one, I'm going to start down here at -3. And it tells me a -2/3 means I'm going down 2 to the right 3. So 1, 2, 1, 2, 3. And to get a point up maybe in the top left of the graph, we can do the opposite. And we can go up 2 and this time to the left 3. 1, 2, 3. That kind of helps me get some points throughout the whole. That was a bad line. That helps me get some points throughout the whole graph as opposed to just on one side of the graph. So 1, 2, 1, 2, 3. So now we're going to go ahead and graph our next equation. This one's starting at +4. But again, we're moving down 2 to the right, 1, 2, 3. Down 2 to the right, 1, 2, 3. And notice those lines are never going to touch. They're never going to get any closer together or any farther apart because they are parallel lines. They have the same slope, so these have no solution. All right, let's go ahead and move on down now to, let's look at number 7. So go ahead and turn to page 9, and we're going to start on number 7. For number 7, my first equation has a y-intercept of +1, and it has a slope of -2. Again, a slope of -2 is the same thing as 2/1. So that tells me I'm going to go down 2 to the right 1. So 1, 2 to the right, 1. 1, 2 to the right, 1. And you could keep doing that. I would really like some points up here in quadrant 2. So to get some points up there in quadrant 2, I am going to do the opposite. I'm going to move up 2, but this time I'm going to go to the left. And that really allows me to get points throughout my whole graph instead of just on one side. And now my second equation says y equals -3x. If this is slope-intercept form, I know that my y-intercept is what's off to the back. But if we notice, there is nothing off to the back here. There's nothing off to the back. So that means it's 0. So my first point is going to be right here at the origin, 0, 0. But my slope is a -3. So that tells me I'm going down 3 to the right 1. So 1, 2, 3 to the right 1. If I keep in that going down, I'm going to go off the graph. So I want, again, some points up here in the second quadrant. So I'm going to do the opposite. I'm going to go up 3 and to the left 1. So 1, 2, 3 to the left 1. And now I'm going to graph this. And we can see that they do cross right here. And the point that they cross is our solution. So they cross at the ordered pair -1, 3. And because they do cross, then there is one solution. There is one solution. Let's look down to number 9. So my first equation, I'm going to start at -1. And my slope is just an x, so that means it is a 1. So I'm moving up 1 to the right 1, up 1 to the right 1, and I can keep doing that. I want some points down here in quadrant 3, so I'm going to do the opposite. I'm going to go down 1 to the left 1, down 1 to the left 1. And that really allows me to really see how this should be graphed. Okay, my second equation starts down here at -5. But notice my slope is the same as it was in the first equation. The coefficient of x in both of those is a 1. So we know that the same slope, if they have the same slope but different y-intercepts, there are going to be no solutions. So for this one, I'm going up one to the right one, up one to the right, and we can keep doing that. And you'll notice, again, we have parallel lines. Because we have parallel lines, there are no solutions because they are never getting any closer together or any farther apart. And the last one I want to take a look at is something like number 10, because on a question like number 10, neither one of these are in slope-intercept form, so we need to put them in slope-intercept form. So remember, our goal is to have this in y equals mx plus b form. So the first one is pretty easy to get there. It's really just one step. If I want to get y by itself, then I need to move this x. Right now it's a positive x, so if I subtract x from both sides, they're going to cancel over here, and I'm just going to bring down my y. Now 3 and x are not like terms, so I cannot combine them. So I'm just going to keep this 3 minus x. If we want it in true slope-intercept form, then we're going to put that negative x first. And now we have slope-intercept form. The second equation, we're going to go ahead and put in slope-intercept form as well. So again, we know we need to get that y by itself. So the first thing I need to do is move this 8x. Well, right now it's a positive 8x. So I have to do the inverse or opposite, which is to subtract it, and I have to do that to both sides. On my left, right now I'm left with 4y. And again, I have a 12 and a minus 8x, but those are not like terms, so I cannot combine them. My last step, instead of multiplying y by 4, I need to get rid of that 4, so I have to do the inverse or opposite of multiplying, which is to divide. So on the left, I'm left with y. And if I divide it by 4 on the left, I have to divide each term on the right by 4. So 12 divided by 4 is 3. Negative 8x divided by 4 is a negative 2x. And then to put this in true slope-intercept form, even though we could still graph it like it is, I'm going to put the negative 2x in the front and then the plus 3. Now I can graph these. So my first equation is going to start here at 3. And because this is a negative x, that negative means negative 1. So I'm going to go down 1 to the right 1, down 1 to the right 1. And I can keep doing that. Go ahead and graph that. And let's graph our second equation. This one is going to start at positive 3. Oh, looks like they're starting at the same spot. But this slope is a negative 2. So this slope tells me I'm going to go down 1, 2 to the right 1. Go down 2 to the right 1. Down 2 to the right 1. And as the graph gets going, you can tell that the farther down in the graph they go, like down in here, they're starting to get farther apart again. So we do see that they cross. They cross right here. And the ordered pair of that, my x value was 0, my y value was 3, and because they cross, there is one solution. So again, if the lines cross at any point, there is one solution. If they never touch, there are no solutions. And if they end up being the same line, there are infinite solutions.